Hi lads, in this video I'm going to go through how to 2013 section B question 4 from higher level. It tells us the elevation and plan of a desk organiser are shown. A 3D graphic of the desk organiser is also shown. Part A, draw the given elevation and plan, show all points of contact. Part B, draw the development of the cylindrical surface A, and Part C, draw the development of the sloping surfaces of the truncated pyramid B. So to start this question, I'm going to draw my XY line first for where the base is going to fit. So the base from the question we can see is 10 mil high. So I'm just going to keep this left of the page and allow room on the right to actually fit the developments then. So it's 10 mil thick. Just take that line across there, and then we can see that we go in 31st. So from the plan we can see it that we go in 31st for the centre of the cylinder. I take that centre line up there, and the radius of that is 16, so I can go 16 mil each side. I'll just take those two lines up as well. Then after that we go across 44 for the pyramid, and I give us the centre of that. And then from our elevation are given a height of then 35 and then 55 to find the top of it. So 44 there, and just set it to go 44 the other side. And then that connects to the top there, and connects back down to the bottom there. So the 35 height, that will actually cut off the top of that pyramid there. So I can actually draw that in heavy for now. And then I have a sphere then that is diameter 50 that rests beside that. So if it's a diameter 50, that means that the centre is going to be 25 mil above the ground, or above the top of the base. So somewhere along that line, that 25 mil line I've drawn there, is going to be the centre. So to find the centre, there's two ways. One way is to take a perpendicular line out from here and measure 25 mil, and where they meet is going to be the centre. Or another method, so that would have been the one I would have done for yesterday's video. What you can do as well is you can bisect the angle like this here. When you bisect the angle, it passes through the centre, and that'll give me the centre of my sphere. All I need to do now is find the point of contact. So go in perpendicular to my edge, and it just happens to actually pass through one of my extended lines there. That could be any distance using your compass. Mine just happened to actually pass through it. And then the point of contact with the base will be there then. So I can take that now as a radius 25. And I can draw my circle then in elevation. So there's my circle now in elevation. For the smaller circle, this goes in between from where the sphere is cut in the plan. I'll need to actually draw the plan first. So that's all I can do in terms of that. But I can still label for now my point of contact there. And also this touches the ground here. So that gives me a point of contact for the cylinder, even though I haven't drawn in fully yet. And I can see from the cut on the cylinder there's a 60-degree line taken, which is going upright, which means it's going to be 30 degrees going this way. And that goes from this cut here. So the top of that cut, we take a line out at 30 degrees like that. I'll just tilt this up so you can see the top of the question, because I'll need that later on. So where that happens there, that allows me to actually draw in my sloped cut there for A, and then I can take my 2 lines down there. After that then, I can start moving on to my plan. So I'll get the end of my base later on. So all I have to do now is take down all my points. Now what I'll do is there's my central axis there, and that'll allow me to start drawing the outline of my base in plan. So I can see from the question it tells me it's a radius 30. So I can take this distance here on my compass, which is the same thing. I've already stepped in my 30 here in my elevation, so just while it was blurred there you can see it. Let's give it a chance. Just focus. So that distance there. And that's the outline of my base there. And I can take those lines across then. And then the outline of my base then is swung from the centre here on the opposite side. And I can connect those heavily together then. And just to get my point there, I can now get my full base and my elevation as a result. So I'm going to start with the cylinder on the left hand side. So I take my compass and I take my radius here. So even though it's cut, it still appears as a circle in plan. So only when we look in at an angle we would see a cut, but we don't need to actually do that for this question. In previous years you might be asked to draw the true shape of it as well. So that's that one drawn first. Then I have my actual pyramid in between, and the width of the pyramid is determined by the diameter 50. So what I can do is I can draw in that sphere now, and I'll draw it in lightly because part of it is going to be cut off at the front. So what I'll do is I'll just draw that in lightly there for now, and I'll get the cut part after. So that's determined by the back line there, and then also for the front it extends out to this point here. So my plan, the outline will look like this. So make sure I take down my line there. So there's going to be hidden detail here because you can see the sphere is blocking this section. If we took a perpendicular line down here, it's blocking all this underneath from there, so we can't actually see it. So that's going to be hidden detail behind there, and it actually shows that in the question anyway as well for you. And then we can take that across there and take that across there. Then we just join the diagonals. And then we can take down our cut surface here. As you can see there, they'll automatically line up as well. And then connect our diagonals again. And where this line here, front part of the cut, where that comes across, that gives me that front cut face there as a result. So where that cut actually occurs. And then I can draw in the rest of that outline in heavy then. So draw that heavy in there, and then just go over this in heavy again above. Then the last thing I can do is take these two edges straight up, and that'll give me the radius of my circle then at the front. So that smaller circle, you can actually see that's how you get that radius then as a result. That's it drawn in there. And then that, yeah, that completes the elevation and plan then. So the next part, the points of contact, sorry, that was the last thing I had to do. So all the points of contact, I already have the point of contact here in elevation between the cylinder and the pyramid, and I have the point of contact between the pyramid and the cylinder here, or sorry, the sphere there as well. What I need to do is take that down, and that lies along this line here. So there's my point of contact there, and then my point of contact directly below is going to be that there. So that's all my points of contact now put into the question. So now part B, draw the development of the cylindrical surface A. So basically that one there. So what I would do is, I would just take all of my heights straight across and start my development out here, and then use this section below then to draw the development of the truncated pyramid B, which is going to be this one here. So when you're doing that, take all of your heights across. So all I have for now is my height cut there, my centre line, and my extreme point at the very top. So what I need to do now is divide up my circle in plan 30/60 so I can get evenly spaced points, and then take them up in the actual question then into elevation to give me more heights that I can take across, so I can draw the freehand curve that's going to be left behind when the development is rolled out flat. As always, I'm going to label all my points. So this time I'm actually going to start the curve where it's at its lowest point, and then eventually progress up to top and back down again. In the previous question I will start at a random point. So I'm going to start at the lowest point, which would be here, and call it 0. And take that all the way around until I get to 11 there. All them points can be taken up, so there's 0 there. One, 11 are there. 2 and 10, 3 and 9, 4 and 8, 5 and 7, and then finally 6 at the very top. So I also need to step out my equal distances as well, because we can't just measure the circumference of a circle, we just plot random points along it. So I said I start at 0 here, so I must end at 0 as well. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, and 11 back to 0. And with those, I can just take all of them up lightly for now. So I have 0, 1, 2, 3, and I eventually get around all the way back to 0 again. So the first one, the height of 0, I already have it here. And I go to 1, you see that height there. 2 is that height there. 3 I already have. 4 goes there. 5 is here. 6 is already given. 7 will go back down. 8 will then go back down again to the next one. And I have 9 here. 10 will go across to there. 11 will go to there, and then finish off at 0 again. So you can see the shape I've actually produced now. And all it's a matter of doing then is draw a nice neat freehand curve for the actual question then. And that's my curve now drawn in. And then take down into extreme edges there, across my base, and then draw in my fold lines. So there we have part B complete now. So A is here, B is there, and then part C. So part C is to draw the development of the sloping surfaces of the truncated pyramid B. So basically, what's the true shape of the pyramid when it's rolled out flat? So the first thing excuse me, we need to do is actually find the true length of the sides. So the first thing we need to do is we need to rotate around one of our one of our sides, or one of our corners that's connecting to the apex. So for example, take this corner here. So that there is the length of one of our corners. So we wouldn't just be able to take this distance here straight up. That's not the actual length. That's only the true length down to that section there on the side there. We need to actually take our line down from here. That would be the one length of our corner. So in plan, it's not going to be a true length in elevation as it's tilting at an angle. What we want to do is rotate it around to make it that it appears as if it's now level, because once we have a level line there in plan, it appears the true length in elevation. So I need to take that up. By rotating that around, it now appears as a true length. So we can take that up, and when we connect that to that, just see there when it focuses, that's now the true length. So that's the true length of one of the sides. So we then take that distance in our compass. I'll just pick a point out here randomly to be my apex, and I'll just swing an arc. I'll just mark here as my first point. So that's going to be one side. So I'm going to say that's going to be that corner there. So I'll just label that A, and I'll go around B, C, and D. So the next thing I can do is I can take the distance from A to B, because remember they're not all equal. A connects to B, length of B to C is going to be this one, then it's C to D, it's going to be that distance there, and then finally D has to connect to A again to close off the shape, the background to A. So all these can be connected. So it's not like a cylinder where you just take that outline all the way around. Pyramid has edges going all the way around. And then I'll connect them all to the apex. So that would be the shape now that I have here. If I was to do the development of the full pyramid without the cut, that's what that pyramid would look like there. But with this one, there's actually a cut taken. So we know with elevations, heights always stay the same. So we can take that height across, and then take this distance here. So we take the height here across, take the true length height, and I can rotate them around. And now what I can do is I can connect these together, and this is actually the top surface then. So remembering to put fold lines in between. And then the last one on the outside is going to stay heavy. And then connect all these edges together. And then that completes the question there. So just putting in that that's part C, and make sure to label that that is 2013 question 4. So hopefully that video helps anybody who may have been stuck on that one.